Hi there, we're looking today at some volumes of revolution. Now we've seen a few of these before, and certainly in the lesson I'll go through a couple of these with you, and I've got a couple of nice starters for you. But in this lesson I just really want to make sure for this, this topic we actually make sure we know what's going on. And rotation around the axes kind of fits what we've already seen. Of course, we've already seen that the volume of revolution, we usually write this as the integral of pi times the integral of y squared dx. Now, of course, this is about the x-axis. But if you go around the other way, if you go around the y-axis instead, you get a very similar equation, integral pi x squared dy. So we already know these. As I say, that's the y-axis one. We already know these equations for finding volumes of revolution. Now, notice if you get parametrically stated equations, we get these new versions of the same thing. And because we end up wanting to do, I've said that volume is pi, the integral of y squared dx. But you'll notice I've now got dx dt by dt, and the idea is those dt's are meant to kind of disappear. They cancel each other out. And x squared dy dt dt. So as long as we use this, and we use the limits of integration now quoted in t values rather than x values or y values, then we'll be able to do this. So let's get stuck in. It says the curve shown in the diagram has parametric equations x equals 5t squared and y equals 2t cubed. The part of the curve between 0, 0 there and B 2016 is rotated about the axis. I can see that. That's being rotated around there. And if you do that, my gut feeling is you'll get kind of like almost a cone shape being formed around that axis. Find the exact value of the resultant volume of revolution. Okay then, so we're revolving around the x-axis, so we're using this formula. So we might as well write that down. The volume equals pi, the integral of, and again, y squared dx by dt dt. That's really what we're doing. And if we just go ahead with this, the volume equals pi times the integral. What is y squared? Well, you'll notice I can kind of write y squared. Well, nearly. Y squared equals 4t to the 6, I suppose. So I can write that there, 4t to the 6. But of course I've got t's. They're not x's, so I can't just integrate with respect to x. I need to get rid of that. And how do I do that? Well, I find dx by dt. Well, of course, dx by dt comes here. Dx by dt equals 10t. Just differentiate, times by 10t dt. And now this is the pi times the integral of 40 t to the 7 dt. I need values for t. What are the values of t? It says a is 0, 0 and b is 2016. And effectively I need the first point and I need the second point. So I don't want y values as such, but I can use the y values. For instance, y equals 2t cubed. So 2t cubed equals that 16 there. And if I do that, I get t cubed equals 8, and presumably t equals 2. Just check with the other one. I've got a 20, so presumably 5t squared equals 20. 5t squared equals 20. T squared equals 4. Now you notice when I do this one, it could have been plus or minus 2. T equals plus or minus 2. But the other point tells me it's the 2. So that was the better one to use, effectively. So that goes up to 2 there. And presumably I'm guessing this is 0. Again, I'll do 2t cubed equals 0. You can see t cubed equals 0, t equals 0. So yeah, that does work. So this is now my equation. And that says to the 7, doesn't it? Yes. So it's pi times the integral of 40t to the 7. Well, add a power, divide by the power. So that's 40t to the 8 over 8. I reckon that's 5t to the 8. No constant to integration required because it's a definite integral between 0 and 2. And now I was able to just integrate it because I've used my formula here. Chuck my 2 in, I get 2 to the 8. Whatever that is, menu 1, I think it's 512, 256, what is it? 2 to the 8, 256. I've got times it by 5. 1,280. 1,280. Or pi, don't forget that. And therefore, the reason why I can write that is I've put 0 in, I get 0. So effectively minus 0 equals 1280 pi. That's what I think the answer is. 1280 pi. Good, so it worked out. Now the other thing I want to do in this lesson is not just find volumes parametrically, although that is important. I mean, that idea that I just showed you, that you can replace one of the letters, works really nicely. But sometimes we want volumes between curves as well. And you will recall that in the last lesson we did things like this. So we were finding basically volumes. You might have a curve that looks something like this. And if you integrate between here and say a point over here, you get this curve here. Now if I just integrate, I get the area. But of course if I do, what is it, the y volume for y equals f of x. If I do the integral of pi times the integral of y squared dx between 2 points, I will get that volume, and then, that will be to the x-axis. Again, I'm trying to highlight these things to you again and again and again. So that's to the x-axis, and if I want it to the y-axis instead, and I want to revolve like round this way, it's pi the integral of x squared dy. And obviously we went through how to do those. And you would have to rearrange these things to get what you wanted. And this would be to the y-axis. Now, just be aware they're not always quite like that. Sometimes you get a couple of shapes. You might have a curve like we've had before. Then you might have a straight line as well. The straight line might go something like there. And you're asked potentially to revolve, I don't know, this area between 2 points, maybe that area, and this point here. We'll call this A and B. But you're trying to revolve that one around the axis. And that's a bit trickier because, well, what's it look like for a start? It's getting thicker, I think, is probably the way to think of this, as it goes out. But then it kind of, presumably it's got a hole there, and it's got this, it'd be quite tricky to draw that, I think. But that's what I'm going to suggest it would look like. It would still look like a bowl, because obviously this shape comes round and then down to the bottom as well. But it would, because of this gap here, I think it would be it would have a bottom to it, and that bottom would kind of be like almost like a hole. So harder to draw, definitely harder to draw. Now, based on that, then we might want to revolve it. This is saying be careful. Yes, we are going to have to do y squared. Now, what we've done in the past is big minus small, but what you've got to do here is you've got to square one of them and take away the square of the other one. It's like y1, y2, or this says gx and f of x, depending on which one's the top equation. But let's do this by an example. So this says find the exact volume of the solid form when the region y equals x squared plus 6 and this 8x minus x squared is rotated 360 about the x-axis. So it's broadly like I was saying. We've got x squared plus 6. What's that look like? That looks something like that. And we've got 8x minus x squared. Well, first of all, we can factorize this. X goes in, 8 minus x. What that means is it crosses at 0 because of the x, and it crosses at 8. So if I drew that curve, oh, in fact, I just realized it's an upside down version of what I just drew, because it's a minus x squared. So therefore my curve, might as well switch colours here if I've got a chance. Presumably these do cross. I should now check. X squared plus 6 is equal to 8x minus x squared. Whack those over, get 2x squared minus 8x plus 6 equals 0. Factorize, divide by 2 rather, plus 3. Yeah, you can see it's going to, x equals, well, it's x minus 3 and x minus 1 meaning x is equal to 3 and x is equal to 1 is where they cross. Alright, so this goes up and it comes down, and that point there is at 1, and this point here is at 3 if you draw it accurately. And so this is the shape I've got, and it's this shape that I'm trying to revolve around the x-axis. And so we're going to do this by squaring one and squaring the other. So I'm going to do x squared plus 6. I'm going to square it. And that is x to the 4 plus, I reckon, 12x squared plus 36. And you got it wrong. And the other one, this one, is 8x minus x squared. And obviously that's 8x squared, so that's 64x squared. I've got minus 8x cubed, minus another 8x cubed. So that's minus 16x cubed. That sounds right, plus x to the 4. And what my job is to take this and take the other one and take one away from the other. So again, you basically do one of the functions, doesn't matter which, the top one. I think I call it g of x just now, and you square it. And you do the f of x, and you square it. So if I do that, I think I will get, well, take this as my top one. So it will be that x to the 4 minus the 64x squared, no, minus the 16x cubed plus the 64x squared. And I'm going to subtract all this lot from it, which is the x to the 4, and I've got to be a bit careful here. There's x to the 4 plus a 12x squared plus a 36. So I've got to be a minus and minus. And I'm going to integrate that. Volume is, of course, pi the integral of, now I'm effectively doing the y squared dy. So, dx, sorry. So if I just do this, the volume is pi, the integral, and again, the integral, by the way, is from 1 to 3, so I can use those. And I've got x to the 4, take away x to the 4, so they disappear and don't bother me at all. I've got a minus 16x cubed. I've got 64x squared, but then I take away a 12x squared. That sounds like 52x squared. And I've got a minus 36. Is that a 36? Yes, it's a minus 36 there. Yeah, that works. So that's dx. So if I integrate this, now first of all, it doesn't actually say I have to use algebra. So in the exam, you've got to use your brain a bit. If there's 1 mark for it, you know, for the integration part, just do it in your calculator. And I'm going to do it in my calculator in a bit, but I'm going to do it algebraically first of all. But notice it doesn't say you have to, so I think you're just going to have to use your common sense a little bit. Between 1 and 3 then, if I integrate this, let's get rid of this, let's do the integration, I get minus 16x over 4. Alright, so that just becomes minus 4x to the 4 plus 52x cubed over 3. That doesn't simplify quite so nicely, minus 36x. And that's between 1 and 3. I can just type that into my calculator, put that into my calculator. It's going to be negative 4 times by, well, it's 3 to the 4 plus 52 divided by 3 times by 3 cubed, and then minus 36 times the 3. So that's the first one done. I've got 36 on that. So you'll find out if it's right or not in a bit, I suppose. And then minus, you've got to put 1 into this. So 1's a lot easier. You're probably just doing this in your head. It's negative 4 plus 52 over 3 minus 36. Because, of course, all of that, just anything to the 1 to do anything is 1. So it's, what's that, minus 68 over 3. Of course, I've got to add those together. So effectively, plus the 36 then. So is it 36 plus a 68 divided by 3 is 176 over 3. Oh, the one thing I've forgotten, of course, is that pi. So this is all times by that pi. So I think the answer is 176 pi over 3. Before I check the answer, I'm just going to type into my calculator and get it to do it. Oh, I've run out of work. I've run out of time, so I'm going to have to just say to you, oh look, it is right, but you could do that on your calculator as well. So there's two types of question on exercise 8D that we need to practice. Cheers, thanks very much.